4 molecules of HBr and 1 molecule of O2, how do those things turn into 2 molecules of Br2 and 2 molecules of H2O? Well, given our discussion so far, you may say that the molecules of HBr and the molecule of oxygen have to smash into each other with sufficient energy and in the proper orientation. But that's actually not what happens. Because as you can see here, it says 4 molecules of HBr and 1 molecule of O2. If that were the case, if this reaction happened in one step, where the reactants immediately turned into products, that would require 5 different molecules to run into each other at the same time with enough energy and at the proper orientation. Statistically, that's almost impossible. What actually happens is a multi-step process that we refer to in chemistry as a mechanism. So for that first reaction, it's actually a 4-step mechanism. To go from the reactants to the products, you go through 4 different steps. In the first step, you'll see that 1 molecule of HBr and 1 molecule of O2 have to run into each other to make this thing. Then this thing runs into another molecule of HBr, forming some other product. Then one of these products, HOBr, runs into yet another HBr, forming, okay, something we were looking for, water and Br2. Then this exact same step happens again, where another one of these weird things formed in the middle reacts with one of our original reactants to form the other 2 products. So this is what we mean by kinetics looks at the process of going from reactants to products. Because very rarely is a reaction what we called at the beginning an elementary reaction. Very rarely do what's pictured here, the reactants, turn into the products in a single step. For most reactions, they have a multi-step mechanism by which the reactants convert into the products. Most reactions happen in this sort of way. And then getting even deeper into kinetics, these steps happen at different speeds. And for each reaction, you have what's called a slow step. Now this slow step is determined experimentally. There is not a way you could look at this mechanism and say, oh, okay, I'm deducing that this step would be the slow step. No. The slow step has to be determined experimentally. So, just for the sake of our example, I'm going to say that we did this experiment and we determined experimentally that the first step was the slow step. That brings us to the first I call kinetics truth. That the slow step determines the rate or the speed of the reaction. Once we know the slow step, or better said, once the slow step happens, then everything else happens almost instantaneously. So the slow step is what the reaction is waiting on. So in this reaction, the first step is the slow step. The first step is the one that requires that activation energy to overcome. All the other steps require a much smaller amount of energy. They happen much, much faster. The slow step is what determines how quickly the reaction will happen.